Today we're going to be looking at G-line in your book 2s. Everyone got their second book? So, Gary, do you want? So, it starts on page 75 and goes to page 114. So we're going to try to cover all that today. So I've broken up the day into 3 blocks, kind of from now till coffee to lunch, and after lunch till we finish, kind of thing. So from now we're going to be looking at line G, book number 2, learning tasks 1, 2, and 3. So as you can see over there on the objectives, that would be identify types of stairs and stairwells, identify stair terms, and identify parts of stairs. So have any of you guys gone over any of this in the book yet? Briefly touched on it? Grazed over it? Okay, so I'm going to hand out a booklet that I have made up with 5 sheets on it. So the first 2 sheets are kind of just stair framing terms is the first one. So you got total rise, total run, risers, treads, spring, duals, guardrails, so on and so forth. And then the second page shows pictures of some of the stair parts. So, do any of you guys know what total rise is or total run? So, total rise is the full height of the stairs. So, from the first step all the way to the last step, that's your total rise. We'll be going over this stuff through the book and everything. What I have up here is, it says competency H-6, build straight stairs. This is from the carpentry book, but I was going over it in the RBNW book, and it's almost identical. The only thing that's different is the layout of the books. Okay, so we'll just go through this. Yeah. Follow along in your RBMW books, and again I'll try to match them up so they're on the same page. So you can see on page 79 we start going over identify types of stairs and stairwells. So the first one are open stairwells. So open stairwells have one or both sides open to a room or hallway. All open stairs have a finished balustrade which acts as a guard to protect and give a handhold to people using the stairway. So you can see up on this top left, this is supposed to be the wall, like the darker black lines. That's what they're saying the wall is, and then over here, this is the open part. So, yeah, and then here you got L-shaped stair that's open to the one side. This is a U-shaped stair open to one side. You don't see too many wide open stairs, like where there's no wall on either side. Just safety reasons, but sometimes stairs going into a house, like exterior stairs, they'll just have two rails on them. Those big stairs at VIU, the main campus, the ones in the main building that go up to the 2nd and 3rd floor, those are wide open. There's no wall protecting you from those ones. So. And then closed stairwells have both sides of the stairway closed. A handrail is attached to the wall with brackets on one or both sides. So same thing. These would be more common in houses. This is the one I have in my house, just the straight flight, walls on both sides and handrails. So the thing in common with the open stair and the closed stairs is they all have handrails, and that's a building code specification. So you need something to grasp onto while you're walking up and down stairs. So if you slip, you can catch yourself as opposed to just rolling down. So if you ever see stairways without handrails, they're technically illegal. Unless they're, I think it's like 2 steps on an exterior flight, doesn't need a handrail. Okay, so combination stairwells, that is obviously a combination of an open and closed stairwell. So this one is closed up at the top but open at the bottom, and this one's same thing, open at the bottom, closed at the top. So on the next page, page 80, they start talking about straight stairs. So straight stairs have no turns, no angles or curves in them. They're just a straight flight. Yeah, nothing going on. They're pretty much the easiest ones to figure out because they are straightforward. You don't have to do any funky math or anything to figure those ones out. And again, they're probably the most common in residential building. So the next thing are landings. So they define it here, landings are used to either change the direction of the stairs or to break the total rise up into smaller amounts. So it says the building code requires a landing every 3.7 meters vertically. So I think that's 12 foot 1 inches, if I remember correctly. So the reason for that is if you have like a 20-foot flight of stairs, you don't want someone falling at the top of those and falling down every subsequent stair. The plan is the landing, they'll fall whatever, the most they'll fall is 12 feet, and then they'll stop, catch their breath, and then they can fall the rest of the 12 feet or whatever. So it says that they need to be every 3.7 meters vertically. So if this right here was 4 meters down here, you wouldn't go 3.7 meters and then have the landing up here. You'd want to split it like they did in half. So you'd have whatever, 8 steps up and then a landing and then another 8 steps up. You wouldn't want 14 steps and then a big landing and then 2 steps to finish off. That would kind of look funny. Okay, so a flight of stairs is from one landing to another. So, you know, a flight can either be from one floor to the next or just from one landing and then another flight to finish off the floor. A stairway may have several flights of stairs. The unit of rise for each step in a flight must be equal. The unit of run must also be equal from step to step within a flight. The building code does not require the unit rise or unit run to be the same from one flight to the next. So what they're saying is, from here to here, each one of these steps should be 7.5 inches or 8 inches or whatever it is. They should be equal all the way up. So if this is 8 inches, then this has to be 8 inches, that has to be 8 inches, that has to be 8 inches, and so on. Same with the run, which is the part that you actually step on, the tread. If that's going to be 10.5 inches, then this one has to be 10.5, that one has to be 10.5, and so on. But from flight to flight, they don't have to be related. So this can be a rise run of 7 inches and 10 inches, and this can be a rise of 8 inches and a run of 14 inches if it wants to be. Yeah, it's kind of one of those weird things that you wouldn't think would affect people too much, but if you're on a constant step going up a flight of stairs and then the last one's longer than the other one or shorter than the other one, you hyperextend your leg. I don't know if you guys have ever done that, walking upstairs in the dark. You hyperextend your foot, kind of hurts. But for some reason, the way the mind works is if you're going up 7 inches every time, and then you get to here and you go up 8 inches every time, your mind just adjusts quickly enough that you won't notice. So it's okay to be different on flights of stairs, but it's not okay to be different on individual steps. Any questions on any of that stuff? So you are allowed to be a little bit different, obviously, because we're cutting with saws, right? So it's not every flight is, or not every step in a flight is going to be exactly 7.5 inches. The building code says that you're allowed a 5 millimeter difference, so a little more than 1/8 of an inch is okay to be out. Yeah, so they don't really check that, but again, you'll notice a difference if you're an inch difference between steps, but you won't notice it if it's a 1/4 inch or whatever. So next for you guys on page 81 is the wide L stair. So this is, again, we're just trying to identify what types of stairs these are. Like there's straight flight, this is wide L stairs. So, this would be in the corner of a house or something. And you go up, turn 90 degrees, and then keep on going. The double L stair, really rare. I doubt you'd see this anywhere anymore. I'm sure they exist, but so you can see again, like there's 2 L's there, right? One in the bottom corner, one in the top corner. And then there's 1/4 turn stairs. So 1/4 turn stairs may use a landing or have winders where the stairs change direction. So this picture here is showing winders. So what a winder tread is, it's just a tapered stair. So most stairs are equal the whole way, but a winder tread has a wider on one side and it tapers down to a shorter inside measurement. So you'd either have that, or like in the YL you would just have a straight landing. Any questions on winder stairs? We'll talk more about it in a sec, but so the purpose of those is just so you don't have like one big ugly landing. It's just a continuous gradual walk up the flight of stairs.
You need to take a break on it too.
Yep. You get winded. Okay, next there are stair terms. So again, this is that first page that I gave you in that handout. So feel free to fill that out as you're going along, or wait till after to do it as homework, or I'll give you some time to do it too. So like roof framing, stair construction comes with associated terms. So the terms are, it's pretty important to know the terms, just so when you're talking to people in industry, you guys are all on the same page. Like, I don't want to be sitting there telling you, oh, build this tread at 10.5 inches, blah, 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 and then you come back and you built me a riser that's 10.5 inches, because we weren't talking in the same terms. So, and with stairs, most of the terms are always going to be the same. Like, you hear some people call a circular saw a skill saw. stuff like that. That doesn't happen with stairs. Everybody calls the total rise the total rise. There's no other term for total rise. So again, total rise, the vertical distance from finished floor to finished floor. So from the bottom stairs down there up to this level, that's the total rise, and that's stairs up in the hallway there. Oh, anyone know what those stairs are?
7.5.
What's that?
I think like 7.5 or something.
Oh no, like what? Like are they wide L, double L? I'll take a guess. You walk up them, and then there's a big landing. You turn a corner, and then you continue walking up.
Loads still
Yeah, they are closed. Okay, so total run. So the total run is the horizontal distance from the face of the bottom riser to the face of the top riser. So I got this. This is a stringer it's a cutout stringer. So total rise is from here to here. Total run is from here to here. So this total run is about 42 inches. And the total height is, or the total rise is 28.5. So that gives you kind of a visual. So where are we? Page 82 of the book. So headroom. So this is the headroom from there to there. So when you're walking down, and at my in-laws' house, I always hit my head on their stairwell because their headroom is wrong. For the minimum you're allowed is 6'5", so their headroom I think is like 6'4", so I'm always smacking my head on it when I walk down. And I think that was because when they framed it to 6'5", but then they started putting on drywall and treads on the stairs, and it shrunk it. So now every time I walk down, I wang my head. So headroom is an important thing to be wary of, especially if you got tall people in your family.
Don't run down them.
What's that?
I said don't run down the stairs.
Yeah. Well, I knew a guy in high school. Did you guys ever have Mr. McLeod? Scott McLeod? He might have just been after you guys, but anyways. Or just before you guys, but he was a principal and he was chasing one of my buddies who was in shit for some reason, and his name was Davin. He was running down the stairs. He jumped down one flight of stairs, like stairs just like those ones down there, and then turned the corner and then jumped down the other flight, and when he jumped, he wanged his head on the headroom allowance, knocked himself out, fell down, smacked his head again on the stairs on the way down. And Mr. McLeod was walking down, chasing after him, and he saw him sprawled out on the floor, unconscious. So yeah, don't run and jump downstairs if you're tall. So the nosing line. This fourth definition here. Nosing line is an imaginary line drawn through the outer edges of the nosing on the treads. So you can see it's this dashed mark coming down. And again, on example flight. So this would be your nosing line. that's the nosing line. So from here, from this imaginary line that goes through to the top of your headspace, that has to be 6'5". Next one is the finished opening. So the finished opening is the horizontal distance from the edge of the nosing at the upper landing to the edge of the finish at the other end of the stairwell opening. So again, on this picture, it's from right here to here. So that's a finished opening, and that's what you'll have to cut out of the floor above in order to put your stairs in. Okay, then the stairwell is the opening in the floor for the stairs. So the opening in the floor for the stairs. So it's the same as the finished opening. Just another way of saying it. Oh yeah, and there's the finished opening, and then there's also the rough opening. So what I was saying earlier about how they started putting on drywall, which made the headroom shrink, you also have to worry about that with the finished opening, because if you make your rough opening the size of the finished opening, once you start putting on your nosing and your drywall and everything, that finished opening actually starts to shrink. And you got to watch out for that, just for building code and for the headroom, obviously. Okay, so anyone know what a stringer is? That's these bits. So this is a stringer. It's got to be at least a 2x10. Yeah, and this is a cutout stringer. It's actually a mitered stringer, but I'm only showing you the cutout side, so I'll explain all that later though. So next we got the unit rise, which is the vertical distance from one step to the next, and the unit run, which is the horizontal distance from one step to the next. So you can see in this little picture, that's the unit rise, and that's the unit run. So if you have 10 steps in a flight of stairs, if you multiply your unit run by 10, that gives you your total run. And same with the total height. If each step is, say, 7 inches, and there's 10 steps, or 10 risers, 10 times 7 is 70 inches, so that would be your total rise. So tread is the horizontal board that forms the step, and the riser is the vertical board placed between the treads. So this is where it gets a bit confusing, because what we're saying is this is the unit run, but it's also the tread. So, but if you have nosing on your stairs, your treads are actually going to be bigger than your unit run. And same with the unit rise. Like this would be your unit rise, but your riser might not be that size, depending how you lay out your stairs. So in this case, the unit rise is probably 7 inches. So my unit rise is 7 inches, but my tread, or my riser, is actually only going to be 5 inches from there to there. And that's just the way that the stair is laid out. So that's something that you always got to kind of watch out for. So just understand the difference between unit rise and riser, and unit run and tread. So when we're talking about unit rise and unit run, we're talking more about the mathematical part of it. like figuring it out. And then the riser and the tread are the actual things that you step on and step over on the steps. So nosing is the projection of the tread or floor beyond the face of the riser board. The term nosing also refers to a molding that can be applied to the edge of the floor. So on that little step there, the nosing is the part that's overhanging, that 1 inch part that I was telling you guys about. And then next is the stringer support board. So it's usually 19 millimeter thick plywood nailed or screwed to the stringers and to the header of the stairwell. So this is the stringer support board. So if this wasn't on here, and this was your floor coming up, say your joist landed here, you wouldn't be able to attach that to the floor joist without this stringer support board. So all it does is just, it gives you your last rise and something that, it holds all these stairs together. All the stringers are one now, and then once they're together you can screw that onto your header for the stairwell opening, and then that makes it all supported. Here we go.
Hey guys.
Learning task 3, identify parts of stairs. So again, some of the stuff we've already talked about. Stringers. The stringer is also called the stair horse or carriage. It's not called that anymore. I've never heard anyone say that in whatever, like 15 years. So
I'm going to bring it back.
yeah, bringing it back. So yeah, stringer is again that piece there, the one that actually cut out of the 2x10. But there's lots of different types of stringers. It can be a cutout stringer, which is the SPF stuff you see there. That's a cutout stringer. Dadoed stringer, cleated stringer, housed stringer, solid, or made up of 2 pieces, a cutout and solid piece. So if it's a cutout and a solid piece, that's called a semi-housed. So I'll explain that a bit more when we get there. Oh yeah, it can be mitered or laminated into a curved stringer. So this is actually a mitered stringer. Again, all I've shown you is the cutout end, but all of these are actually cut on 45s. So the way that works is, if it was just a straight cutout stringer, like this one, when you put your riser board on, you'd have that end grain. That would always show, and you know people don't like end grain and stuff. So if you miter it, and then you had your riser, it's gonna fall again, and then you had your riser cut on a 45, when you put them together, there'd be no end grain. So that's a theory behind a mitered stringer. Okay, so first we got the wooden stringer. So the minimum size of wooden stringers is 2x10. If it is not supported along its length. If the stringer has a support wall below it, The thickness can be reduced to 1 inch. The 1 inch thickness is its actual, not nominal thickness. So all they're saying there is if the stringer sits like this, where, you know, it starts here and that's where most of the support is, and then it goes up to the top where it picks up the other bit of the support, it has to be made out of a 2x10. If there's a wall directly below it that this sits on, then it doesn't need to be thick at all. It can just be a 1 inch piece of whatever lumber that you put on there and make steps out of. Because again, the wall would be supporting the actual staircase, whereas in the cutout stringer, that's actually being supported by the stringer, so it has to be a lot thicker. The next one is a cleated stringer. So cleated stringers are usually used in outdoor construction. They're kind of a cheater way of doing it. All you would do is take a 2x10 that's not even cut, and you just put cleats on it, or ledgers, or whatever you want to call them, and then okay, next is the dadoed stringer. So that's on page 85. So dado stringers are usually used in outdoor construction. Dados are cut into the insides of the plane stringers to receive the ends of the treads. So you don't really see too much of dadoed stringers, but you can see here that everyone knows what a dado is. It's just a continuous cut. You don't cut all the way through the piece, you cut like halfway through it. We did a bunch of them last year in the intro to trades when we were building the toolboxes. The ends were dadoed, so they could fit together. Yeah. Okay, cutout stringer. Cutout stringer is the most common type of stringer. Most common type of stringer used within buildings. The unit rise and unit run are laid out on the face of the 2x10 and cut out to support the treads and risers. Hey Jeremy, can you go grab me a framing square from the C-can, please? Ask Emily to grab one if the C-can's locked.
Like the speed square or something?
No, the framing square, the big one. The one that looks like a giant L. Oh no, never mind, we got one right here. Thanks. So this bit here, the unit rise and unit run are laid out on the face of the 2x10. So if this weren't cut, I would find my unit rise and my unit run. So say it was 7 inches and 10 inches. I'd hold the square and then I just put it on the face of the stringer. And then I'd make my mark. So like this used to be continuous, right? Like it used to look like this all the way through. So then I put my unit rise and my unit run on, and then I cut them all out to give me this look. So we'll go over how to use this later on in the day, but okay, next we got the house stringer. Hey, how's it going? You got your books with you? Okay. Where were we? Oh yeah, the house stringer. So house stringers are using finished stairs. So, you know, I don't think as RBMWs you'll see too much of them. Even as carpenters you don't see much of them.
House stringers?
What's that?
House stringers?
Yeah, they aren't very common. Just because they're so hard to, like they're really nice and they look good and everything, but they take quite a while to do. So in this case, a template is made for the unit rise and unit run of the stairs, which includes an allowance for wedges to tighten the treads and the risers in place. A router is used with the template to cut a gain or a recess into the sides of the stringers. So if you had this full piece, instead of cutting out every rise and run, you would cut kind of like a dado for the rise and the run. Dado the rise, dado the run, dado the rise, dado the run. And then you would just kind of fit the boards into those dados. And again, that hides. So all you would have is like this piece with the dado cut. I'll have some handouts on here. So you have this piece with dados cut into it, and then the risers would be recessed into them. So again, that would hide all of your end grain cuts and make it look nice, right? Semi-house stringer. So the semi-house stringer is it's got two parts: a cutout stringer and a plain stringer. The plain stringer is a finished piece of wood attached to the wall. The cutout stringer is placed over the solid stringer. The treads and the risers butt into the finished stringer. So semi-house you'll see a lot more of. It's a cheater way of getting around making a house stringer. So what you would have is, this would be your cutout stringer, and this would be your plain stringer. So that was backwards. There it is. So when you have it like this, and you put your riser board on, you don't have that end grain showing. This is a nice, like this would be MDF or some sort of nice finished material. And if it sits on there like that, then when the piece butts in, all you see is a nice finished tread and the nice finished house, or the nice finished plain stringer. And this cutout stringer is completely hidden. It's still functional, like it's what's holding the stairs together and everything, but you hide all the ugly parts of it. So you can kind of see that there, maybe. So this is your plain stringer, backing stringer, and this is your cutout stringer. So when you put your riser on top of this, it covers the cutout stringer, and then the backing stringer covers the end grains of all your cuts and everything. So down here it says the semi-house stringer gives the same effect as a house stringer. So it gives the same effect, but it takes, you know, half the time, a quarter of the time to do a semi-house stringer than it does to do a house stringer. So page 87, we got the mitered stringer. Mitered stringers are used in finished stairs when one or both sides are open. They can be used in combination with the house stringer on one side and the mitered stringer on the other side, where the riser board and the stringer meet on the exposed side and the edge is mitered to hide the end grain of the riser board. So kind of what I was talking about before again. You don't want to have end grain on a finished flight of stairs. Maybe on exterior, but on interior you want everything to be covered up. So you accomplish that by using the mitered stringer. If that. And then lastly, on page 87 is the curved stringer. So circular stairs can be built from wood, concrete, or steel. Wooden stringer used in circular stairs are made of laminated layers of thin plywood. The stairs are usually manufactured in a stair building plant using curved walls to form a jig. The finished stairs are shipped to the job site and installed in prepared floor openings. So, again, I don't think as RBMWs or even as carpenters you're going to be making curved stringers. The jigs that they're talking about in this book are huge. Yeah, like there's specific job where all you would do, like you'd work in a stair plant, and all you would do is build curved stairs, and you'd ship them out across the country. Like there's probably, I don't know, 10 or 12 curved stair plants in Canada, and they ship across the country. Just because it's not a common thing to see anymore. Just because they're so expensive. But really cool to build. I've built a curved set of stairs before, and it was pretty fun. Okay, page 88, we're on treads. So this is just more of a definition. Again, if you're following along on that handout I gave you, when you're trying to define the terms of tread, you might want to use this stuff. So treads are the horizontal boards in a set of stairs. That's the definition for it, I guess. That's it. All this other stuff is just the icing on the cake, I guess. So the minimum thickness of treads is 1 inch actual thickness, with one exception. If open risers are used and the distance between the stringers exceeds 750 millimeters, the treads must be at least 1.5 inches thick in actual thickness. In a straight staircase, the treads are rectangular and even, but curved staircase require the use of tapered treads. Treads should fit closely to the level surfaces of the stringer. Any variation should be plain smooth before installing the treads. Glue the treads in place using construction adhesive. Galvanized nails or wood screws would be used to attach treads to stringers. So anyone know why you want to use construction adhesive on the treads? Nope, no thoughts? Construction adhesive is, or like the glue, it's used to prevent squeaking. So something like stairs would squeak so much if you didn't glue them and screw them.
Mine does.
What?
Mine does.
Yeah. So what happened was someone probably used nails and construction adhesive, or they used screws and not construction adhesive. So screws form a tighter fit, so it doesn't move much. That's what squeaking is, right? It's two pieces of wood rubbing, like the friction causes that squeaking. So if you have the glue in there, it prevents that friction. It gives another medium for everything to rub up against. The next bit is on the risers. So risers are usually made from plywood and fill in the space between the treads. So the treads have to be 1 inch thick. They're usually 1.5 inches thick because that's where all the weight is coming down on. The risers can just be plywood because you don't actually step on the risers. The risers are only there so you don't kick your foot through the opening. They should be cut to run past the back of the tread as shown in figure 8. This allows the riser to be nailed to the back of the tread. So you can see here that the riser starts at the bottom of the unit rise and ends at the top of the unit rise. So those stairs there, that little flight, those are built wrong. Because the treads go right to the back, where the book is saying they should be the riser board thickness away from the back of the. And that's just so you can nail this tread in through the riser. If the riser was sitting on top of the tread, you wouldn't be able to nail it together. So. Which again wouldn't be the end of the world, but if you're doing things properly. The joints between the risers and treads should be glued together as well as nailed. Construction adhesive is the best for the type of glue for this operation. Okay, so any questions on any of that stuff? So we'll go over to this first sheet that I gave you. And we'll just see how we all do. So I'll start there and work around. If you don't want to do it, just say pass. But you know, try at least make an attempt at it. I don't want to hear everyone say pass and then have me recite what I just said. So Derek, what would total rise be?
The vertical distance from the finished floor to the finished floor?
Yeah, exactly. So total rise is your total vertical distance. And feel free to write these in there as you're going. That way you can use this as a study tool later on. Ramsey, you weren't here for it, but total run?
Pretty nice.
Pass? Alright.
I'm just going to read this
Okay.
one.
Mike?
You just gave him?
Yeah, total run.
The horizontal distance from the base of the bottom riser to the base of the top riser.
Exactly right. Desired rise. We didn't get into desired rise. That's something we'll get in later, later on. So we'll skip that for now. Headroom requirements. What's meant by that? Dalton?
The vertical distance from the nosing line to the underside of the floor above.
Yeah. Good one. Gary, you want to tell me what a riser is? Pass. Brent? Want to take a stab at it?
Pass.
I don't think you were there for that, but. Jeremy, you know what a riser is?
No.
Okay, so the riser would be the piece that fits in between here. So this would be the riser board. And remember, it's different from the rise. So this is the unit rise, but this is the riser. Derek, you want to tell me what a tread is?
The horizontal board that forms the step.
Yeah. So these are the treads. So the treads are the horizontal counterpart of the riser. So risers and treads are together. Stringer, Mike?
The stringer is also called the stair horse or carriage. It can be cut out. Is that word?
Dado, maybe? Yeah. So this is the stringer. these are the stringers. So this flight of stairs has 3 stringers. It's so small that it probably only needs 2. Like you get rid of this middle one. But the middle one would be there. Like if you made this out of 1-inch thick material instead of 2x4s, you're just using 1 inch. You'd probably want the middle one in there just to support it. So when you step in the middle, it doesn't sink down. And then all this stuff is what we're going to go over now. So don't worry about the newels and handrails. So if you go to the second page of this handout booklet I gave you, there's a bunch of pictures, and that matches up perfectly with page 89 of your textbooks. It's the exact same picture, so if you're doing this for homework later, maybe close your book, see how well you do at this, and then you can go to page 89 to check your answers. So we're on parts of a finished stair. So you can see here there's the rail, which is the part that you actually grasp. The gooseneck, which is the part of the rail that kind of finishes the landing here. Angle newel, balusters, nosings, treads, risers, and the starting newel. So the balustrade, or balustrade, balustrade. Balustrade is a complete railing including newel posts, handrails, balusters, and buttresses, or buttress caps. So that's kind of something that trips people up, because there's something called a baluster and then there's something called a balustrade. So you got to know the difference. The baluster is an individual component, and the balustrade is the entire thing. So on page 90, we're going with we're going with nosing is the first one there. So we've talked about it a bit already, but here's the actual definition that you guys can highlight or whatever and use it on that worksheet. So nosings are the front edge of the tread which may project past the face of the riser. The projection should be a minimum of 25 millimeters, which is 1 inch, right? If a nosing is not used, the riser should slope backwards 25 millimeters. So the balustrade or banister is the complete unit of the newel post, handrail, balusters, and buttress cap. It is used to protect the open sides of the stairs and landings. So again, the balustrade or the banister is keeping you from falling over. That's what that does. So then the balusters are the small uprights under the handrail that close in the open sides of the stairs for safety. There are many styles and shapes, from very plain square balusters to very fancy turned balusters. Building code requires the balusters to be spaced such that a 4-inch diameter object cannot pass through them. One of the dangers of improperly spaced balusters is the chance that small infants may get their heads stuck between the balusters. So, where's a good picture of that? So here, this distance can't be more than 4 inches. Because if your kid's on there, they stick their head through and then they get stuck. I don't know. Happens on cartoons. So yeah. I guess it could happen in real life. So the thing that a building inspector would do, you take a 4-inch block of wood, and you go between each one of your balusters and check. And if that 4-inch block can fit through, then your stairs fail because they aren't safe for infants. But again, I mean, how many infants are crawling up and down stairs?
Yeah.
That's kind of the whole.
Just like if you buy an Xbox, there's a picture of a baby in a bag, it's like slowly putting on its head.
Yeah.
Don't do this. Yeah, I'm gonna give my kid this.
Yeah.
Here, play with
I can play my Xbox and you play with this plastic bag.
Society's stupid.
Okay, handrails are formed in several standard shapes. They form the rails used between the newel posts. Some have a recess on their bottom surface to take balusters, others are attached to the wall with handrail brackets. So the handrail, materials used as handrails must be graspable. The maximum perimeter or circumference of a cross section of the rail must not exceed 155 millimeters. So that's 6 inches. So a handrail has to be able, like you have to be able to grasp it with your hand. If you're falling and you know the handrail's a big timber and you go to grab it and your hand just slips off, it's not doing anything for anybody, right? So again, all this safety stuff is because stairs are inherently dangerous. You know, old people fall down them, break their hips. Pregnant ladies fall down them and have miscarriages, at least in soap operas. So the whole point of all this stuff is to make them safe as possible. So that's where all this handrail has to be graspable. Nothing bigger than 4 inches. Blah blah blah. All that stuff. Again, they're stairs. They're going to be dangerous, but we try to make them as safe as possible. Buttress or stringer caps can be used under the balusters. It is shaped to take the end of the baluster and is used in railings and landings or on top of the stringers. Fillets or fillets, I don't know. Fillets? No, I'll call them fillets. Fillets are shaped to fit between the balusters under the handrail and on top of the buttress cap as shown in figure 16. So here you have your baluster, and then right here, and if this was done differently, you'd have it down here too. That's where your buttress caps and your fillets would be. Just so, you know, right now the way this stands, you just have a round piece sticking out of your tread. So that might not look the best. So if you put a buttress or stringer cap on there and then put fillets around it, it gives a nicer finish. Again, you probably won't see too much of that because it's higher end stuff, and even then, chances are someone else will probably do it because there's specific people that do finished staircases. It's not really like a general carpentry thing anymore. So the newel posts are the main posts supporting the balustrade. The 3 main types of posts are listed below and identified in figure 17. So the starting newel, which is at the beginning, so it's at the bottom of the stairs and it starts the stairs. Then there's the angle newel, used at the turn of the stair, and then the landing newel is used at the top end of a stair. So the newel posts are bigger, thicker posts, and then the balusters are the tiny ones that go in between the newel posts. It is important to anchor the posts securely in place. They are subjected to strain when people pull on them to ascend the stairs or use them to swing down to the bottoms. The starting newel should extend through the floor and be securely blocked to prevent any movement. So, I don't know if you guys have gone downstairs and you grab the handrails and, you know, just kind of swing down them. So, if you just put your, like this newel post goes all the way down to here, and normally it would probably go into the subfloor a little bit to block it and make it good. If this is just on here, like one of these balusters, if you hit that or anything, you go right through it and, you know, crash and bang. Which would not be good. Was there any questions for all that stuff we just went over? Nope. Alright. We'll just go over them together. There's enough of us here that we can do this fairly painlessly. So, start with Brent. What are the newels?
The posts that fill in the gaps, the openings on the staircase.
Yeah. What are the three types?
The starting newel, the angle newel, and the landing newel.
Cool. Jeremy, do you want to take a guess at the handrails? Huh? Fast? Alright. Gary?
Handrails are formed in several standard shapes. The form of rail used between the newel posts on the creases on the bottom surface to take balusters that are attached to the wall.
Yep. So, feel free to read out of your books, but if you're just reading directly off of it, you might not get what you're reading. So, just understand that the handrails are the part that you use, put your hand on when you're walking up and down. Okay, Gary, that's exactly right what you got there, but you might not be able to remember that verbatim for a test. So, for a test, as long as you know that a newel is the big post that everything is structurally supported to, then that's good. Again, if you're trying to remember what a newel post is and you want to memorize that entire page, you know, that's probably going to take you a lot longer than just kind of visualizing what it does. Okay, Dalton, you want to go for guardrails? So, guardrails are not in that book, I don't think. So, I'll just quickly tell you what they are. So, a handrail is something that you actually grasp onto as you're descending the stairs. A guardrail is something that's there to, it's not necessarily graspable, but it's there to prevent you from going over. So, like if you had, I don't know, have you guys used those stairs at VIU? Not the big concrete main ones, but the ones like that you use at the, like if you're leaving from the carpentry shop to the building, you go in through that back door where all the smokers are. Those stairs there, that's a guardrail system. So there's the actual guardrail that prevents you from falling over the sides of the open stairwell. And then on the guardrail, there's also a handrail that you use to hold on to. So, but again, like if you look at our picture, that guardrail is just a handrail. So it's kind of acting as both instead of just being one. Mike, you wanna tell us what landings are?
Landings are used to either change the direction of the stair or to break the total rise up into smaller mounds.
Yeah. Anyone want to tell me when you need a landing for breaking up a stair into smaller amounts?
12.2.
12 foot 1 inch is when you need it. I think it's 3.7 meters. Ramsey, you wanna tell us what a baluster is?
I think you're getting a call.
Yeah, no, I'm ignoring it. Yeah.
No, just grass.
That's
There are small uprights under the handrail that close in the open side of the stairs
yeah.
for safety.
And this is for anyone, what's the magic number for balusters? How far apart do they have to be? Or what's the maximum distance that they're allowed to be?
4 inches.
Yeah. Good job. Again, that's so no babies stick their heads through. We're tiny people. And then the balustrade. Anyone want to take a shot at that? So the baluster is the individual posts, and the balustrade is this is for anyone.
Balustrade.
Yeah. So this is the balustrade, the whole thing. The newel posts, the handrails, the balusters, the fillets, the buttress caps, all that, like the whole thing put together is the balustrade. So again, you might want to just know the difference between the baluster and the balustrade, because there's such similar words that on a test they might trip you up. Stairwell opening. So the stairwell opening is just the opening in the floor that the stairs go to. And the nosing line. Does anyone want to tell me what that one is? So this is the nosing line. It's that imaginary line that goes from nosing to nosing. And that's the one that you use from here to the top to get your headroom. Okay, so if you weren't filling that out as we were going through it, feel free to do it at home or whatever. Okay, so the next thing I'm going to ask you guys to do, if you could all take out a piece of paper, like a scrap piece of paper. Okay, so this is just an exercise at the end of what we've just done. And I want you to answer 2 questions. So just anywhere on the piece of paper, write down something important that you learned when I was talking there and showing you stuff. And what important question remains unanswered. So if you're still not clear on something, just write it down. And then that way I can try to clear that up. And once you guys have done that, you can take off for a 15-minute break, and we'll meet back here at 11:15. So if you do that quickly, you can get a 20-minute break. And the reason I do this, for the first one, a lot of people, they go home, oh, what did you learn in class? Nothing. But obviously, I mean, you've learned something in class, at least I hope you have. So this just makes it come to the forefront. And then obviously the second question just helps me find out what areas I grazed over too quickly. Again, I'm talking about stringers left and right, but maybe you guys don't know what a stringer is. Maybe I didn't explain it well enough. So, yeah. Okay, and when we come back, remember we're block B, so we're going over the Pythagorean theorem. So put on your thinking caps. Just let me know when you're ready and I'll pick up that piece of paper. And you don't have